We have some new friends with us today. I'm curious, Jay, are those your guests?
Yeah, those are
All
my
right.
guys. So,
Cool.
yeah, we've got Mike and Nick, both people I met at blockchain events here in Austin.
Oh, cool.
What's up, guys?
Yeah, I think I might have fixed my audio settings and things. You guys can hear
Yeah, yeah.
Yeah, we can hear you now.
me? Yeah, I watched your that video posted yesterday about Erlang and the K framework. It's pretty interesting, but I don't know too much about what you guys are working on, so just kind of listen.
Okay. Yeah, cool. Well, nice to have you, Mike. Hi, Nick. You want to tell us about yourself?
Hey, can you all hear me just fine?
Yeah.
Okay, cool. Yeah, so I'm actually working on a blockchain project myself, dealing with we're trying to create our own calculus based off of just regular lambda calculus. We want to add tag typing and stuff too, so we can achieve functional equivalence to create a very small set of UTXOs or a finite set of UTXOs to represent smart contract functions. So it sounds a little bit similar to what our change is trying to do. So I was talking about with Jay on Monday, and it's very interested in hearing more.
Yeah, and it's not even necessarily that our chain is based on the UTXO model, but Josh, you had an idea a while back.
Yeah.
Talking about it.
Yeah, that also seems very interesting to me. The divergence away from regular UTXO to get as concurrent as possible with these channels. That's a new thing that I have not really heard before.
Yeah. Yeah. I'd be happy to dive in there, or we can. So the way we've done this meeting is like it started out mostly being our chain people, and so we were talking specifically about CBC Casper, and now it's a little more diverse, and we generally talk about like whatever interesting consensus thing is on someone's mind, and they're like prepared to talk about on that given week. So I'd be fine to talk a little bit about the design that I had in mind, like UTXO based process calculi, or we could talk about, well, yeah, anything you guys want, really. Yeah.
Yeah, I'd be curious to hear more about what it is you're working on too, Nick. And
Yeah.
Yeah.
sorry,
I'm driving right now. I'm a little distracted.
Sure.
no problem.
Yeah.
Yeah,
Well, just real quick, can you guys sort of explain more what you're talking about with the consensus or sidechain with the UTXOs? Like, I mean, I kind of understand all the words you're saying, but I'm not getting the concept behind it.
Yeah, totally. Okay. Is everybody in favor of like starting with like really basics of rocalc and then maybe like the idea about consensus on it?
Yeah,
Or,
sounds good.
all right. I'm going to take the screen share then. Although Nick, if you're driving, this might be more dangerous than it's worth. Just listen, I guess.
be done in like 5 minutes. So
Okay. Yeah, that sounds good. So let's see the place to start. I've drawn some diagrams. Well, I almost want to start a new one today so that we can like go in whatever direction seems normal. So so maybe we'll start with like UTXOs. So I always like to draw these transaction DAGs, so like directed acyclic graphs, where there's like a bunch of boxes and each box is a transaction. And so if we think about this like Bitcoin, when you make a transaction in Bitcoin, you're consuming some inputs. You're basically like taking some tokens that were out there and you're destroying them, and then you're creating new tokens. And the rule in Bitcoin is that the new tokens that you create have to sum up to less than or equal to the tokens that you destroyed. So you can imagine if I have like some UTXO that's worth 10 Bitcoins and I want to send, I don't know, like 3 of them over to Mike, then I'll make this new UTXO that's worth 3, and then I'll send 7 of them back to myself. So this transaction has like 1 input and 2 outputs. And then there's all these transactions going on at the same time. And we could label numbers on every one if we wanted to, but we don't have to. But we can just build up this DAG where every box is a transaction and every line that goes in and out of it is an input if it goes in the top or an output if it goes out the bottom. So is that much familiar probably?
Yeah, I'm following along with you.
Okay, all right, cool. So that's good. This is like Bitcoin's UTXOs. All right, cool. So then like take like another little aside to talk real quick about like, maybe I'll just start with the pi calculus. And the way the pi calculus works is it's a model of computation, you know, in some ways like the lambda calculus. And there's a couple different kinds of processes that you can have in the pi calculus. And the two most important ones are sends that look like this. It's a channel, and then the exclamation point means send, and then you send some value. So that's a send. That's one of the kinds of processes you can have in a pi calculus. And then the other kind is a receive, and it looks like this. On some channel, you're going to listen for some variable, and then you're going to do a continuation. And so that's called a receive. Okay. So you can imagine if I made a pi calculus program that was just these two processes, what would happen is the value in the first process, this value gets sent over a channel. You can think of it like a phone line or something if you want to, or an email address. And then on the other end, someone was listening here. So they're listening. It has to be the same channel. That's, since they're both called chan, this works. The value that I sent gets bound to this variable, and then we do the continuation. So just as a quick little example, imagine we do like x send 5, and then the other process is listening on channel x for a variable that we'll call y, and then dot. And then whatever we can do whatever we want in the continuation here. And so we're going to put some process between the curly braces. And what it says is when that send of the value 5 meets up with this receive of y, since they're both on the channel x, then we say y equals 5, and we run whatever process is in that continuation. Whatever process goes here, I'll just call it p. And in that process p, if there's any occurrences of the variable y, you know, like if we mention the variable y at all, then y actually means 5. It got bound to 5. There.
So that's like the one reduction. That's like almost like a beta reduction in the line.
Yeah, exactly. This is the one reduction. So maybe I can see if this will test my memory, but let's see if we can write this formally. The rules are. Oh, I'm not going to be able to do it, but the rules are you have a send and a receive in parallel. They both have to be on the same channel. And then when you do that, maybe I can do it. Maybe I can do like x bang, some value, hard with, x receive, some variable, then we do p. Then that reduces to just the continuation, just the process p, with the substitution made where the value v that we sent is subbed in for every occurrence of y within the process p. So it basically says like you can take a send and a receive as long as they're on the same channel, and you can reduce them to just the continuation. So for completeness, there's a couple other terms up here, and one of them I've already shown you, p par q, that's called parallel. And this is like the only way to compose processes in the pi calculus. So there's no like do this first process, then do the second, then do the third. It's only parallel computation. So it says like concurrently do these two processes. Mm-hmm. And then if you want something to be sequenced, then the way you do that is you nest the things that happen later, you know, the and then clauses have to get nested inside of continuations here. And then so you wait for the com reduction to happen, and then you continue with the next thing. So this reduction is called the com rule.
Is all of this specific to like a specific language, or is this like really generic mathematical based programming approach?
Yeah, this is pretty abstract mathematics. So basically what I'm presenting now is like something called the pi calculus. And then there's like, in theory, there could be lots of high level programming languages based on it, just like how you have lots of functional programming languages that are all kind of based on the lambda calculus. Yeah. There's a few other term constructors in the pi calculus too, that maybe I'll just mention, but are not so important for like this basic understanding. But one of them looks like this. It's called bang p, and this one is replication. And so what that means is if you have this bang in front of some process, then you basically have like infinitely many copies of that process. So another sort of like reduction rule, but the COM rule is the reduction rule that does computation. There's other just rewrite rules, but there's one that looks like this. If you have bang p, you can rewrite it to p par bang p, and that's called the replication rule. Yeah. So basically, like you can see that we started with a bang p and we ended with a bang p, and we got to pull one out in parallel. So then we can like do that as many times as we want to have as many instances of this process p as we might care about.
Kind of like a fixed point operator.
Yeah.
And it's useful for like storage if you want to store something and like allow somebody to receive it without destroying it. Something like that.
Oh yeah, it's kind of like persistent data a little bit.
Yeah. Hey, what's up, Isaac?
How's it going? Yeah, I jumped in like 10 minutes ago.
Oh, nice.
Sorry, I was hoping to join with my new computer, but I was in the process of setting it up and don't have everything quite ready. So on my phone, man. Yeah.
What operating system are you running?
So apparently, so Debian 10 is the one I'm gonna try and put on this machine, but right now it's Windows 10. So they just make it too easy to fall into the trap.
Yeah.
But that gave me an idea for maybe a blockchain solution for all of this, but we can talk about that later.
Nice. Okay, so far we've talked about UTXOs and we've talked about pi calculus. And so like my big thing that I'm trying to push is we want to marry these things together. And here's why. So if you look at what we have in blockchains today, we have, cryptocurrencies like Bitcoin and a bunch of others that have this really awesome UTXO model. And UTXOs are great because they're so highly concurrent. And just to give you a really concrete example from this diagram that I drew here, if you look at these two transactions don't have any dependency on each other. Like neither one of them consumes an output that the other one creates. And what that means is we don't need to know or care which one of those happened first. And the same thing is true with these two transactions up here. We don't know or care which ones happened first. Now, there are some ordering relationships we care about. Like, for example, we care that this top right one happened before the center one. And the reason is the center one consumes an output that the top right one created. So there we do need ordering. And likewise, the center one has to come before either of the bottom ones because they have that same relation where the bottom ones consumed UTXOs from the top ones. But in general, and when you have a really wide DAG, like, all the Bitcoins that people use all over the world, people who don't know each other and don't interact with each other, there's a lot of opportunities for not specifying an order, like the cases that I've circled in pink. And that's awesome. And that leaves opportunities. So Bitcoin itself doesn't do this. Bitcoin itself still comes up with a total ordering of transactions, even though it's not necessary. But there's other cool consensus algorithms. One of them is Spectre, one is Casanova, that don't do that. They allow this concurrency to stay. And so, okay, so that's one. That's the cryptocurrency side. The other kinds of blockchains that we have today are ones like Ethereum. And Ethereum is totally badass because it's, Turing complete, right? It represents arbitrary computation. But the problem with Ethereum's model is that it's based on basically a von Neumann architecture. The EVM looks a whole lot like the laptop that I'm working on right now. And that means we don't have this DAG-based concurrency. So like with, just to draw an analogy here, if we were to do the Ethereum version, it would look like this. where every transaction has to follow exactly against another one. And this is almost like a degenerate case of UTXOs, because each one of these UTXOs here, you know, like this one, this is basically just the EVM's, whoops, sorry about that, I'm getting a little rocky. Oh, come on. Yeah. That's basically like just the EVM state. So if you think of the entire state of the EVM as a single UTXO, we can still use the same model where like the next transaction just consumes that entire state and gives you back a, you know, a new state, where in reality, it's probably mostly unaffected, but in general, it's hard to know which transactions can commute. Whereas with Bitcoin, with this more like concurrent UTXO DAG, it was easy to know which ones could compute, you know, because I circled them here, right? We have that relationship of like, oh, they don't depend on each other's UTXOs, so they commute. So maybe I'll pause there and see if that makes any sense.
Well, so what I'm wondering is, you're saying Bitcoin is ordering the UTXOs. Do you mean just in the sense that they're like they all go to a unique like hash pointer, or like Merkle tree root or whatever, and that's ordering dependent?
So, well, yeah, so Bitcoin's ordering the transactions, I guess, not the UTXOs. So it's ordering like the boxes that I've drawn there, but not the lines that connect the boxes. Yeah, and the way that they order them is when they put them into, so you know that every block in the chain is ordered, right? This diagram I drew here is not the blockchain. This is the underlying transaction DAG. And then
Right.
when you build the blockchain, of course, that's totally ordered, right? Every block has exactly one predecessor. And then within the blocks, there's also an ordering of the transactions there. So, you know, you make your block and you say, like, here's my parent hash, here's my nonce, here's any additional data I wanted to jam in, and here's a long ordered list of transactions. So then the total, so basically here's what I'm saying. So Bitcoin has this UTXO DAG like we have on the left side of my screen, and then it goes to, it says like, okay, we have to come to consensus over this DAG, because one thing that I haven't shown yet is sometimes you might have a transaction like this, and now we've got a problem, because that big blue blob, that represents a double spend. So the top right transaction created a, you know, this output. Maybe I'll get rid of the other output just for clarity. Okay, so the top right transaction created one output, and then two different transactions tried to consume that same output. They both tried to spend those coins. And so now we need to come to consensus over which blocks are actually in the DAG. And the way Bitcoin does that is by basically just numbering them. So they'll say like, this one is transaction 1, this is transaction 2, 3, 4, 5, and this double spend, this one doesn't get a number because it doesn't go in the DAG. We reached consensus over its competitor, block 3, instead. So here's our design goal. That's all the background. Here's our design goal. We want to come up with a computational model that has the Turing completeness and all the expressivity that Ethereum has, but that has, where its model is compatible with a UTXO DAG like this one on the left, like Bitcoin has. Then once we've done that, we can take it and we can marry it up with one of those concurrent consensus algorithms that I mentioned briefly earlier, Spectre or Casanova or CBC Casper. Okay, so here's the big step then. When we go to make this new blockchain runtime environment, we're going to use the pi calculus. So the math research that's already out there, by the way, if you want to look this up more, the guy's name to look up is Robin Milner. So he's the one that did most of the pi calculus research. So we already know that anything that can be expressed in a Turing machine like the EVM can also be expressed in the pi calculus. So we're not going to lose any expressivity that way. Now the question is, can we make these pi calculus transactions look like these Bitcoin transactions? Can we make them into a DAG structure? And so the answer is we can, and here's my idea. PyCalc transaction DAG. All right. So I think it's most insightful to not start right from Genesis, or maybe I will actually, but the top part is not that interesting. So we can think of these first couple blocks, or transactions, I should say. I don't want to call them blocks because they're different than like the blocks in the blockchain. These can all be deploys. You know, maybe we just add some new code into we call it the tuple space, is the state of the whole machine. So maybe each one of these deploys some code. So that left one deployed 2 terms. So maybe it was like X bang 5, so send the value 5 on channel X, and in parallel, Y bang 3 or something. And so now we've got these 2 new UTXOs. This left one is a send of the value 5 on X, and the right one is a send of the value 5 on Y. And similarly, this middle block only deployed 1 new term, and the right block deployed 3 new terms. So that's how code gets in there. That's basically like deploying your smart contract into the EVM, deploying your code into the token space. And so then the questions are like, it's starting to look like a DAG already. That's great. But like, okay, our goal was to be able to do something that looked like this, and then simultaneously something that looks like this, and not need to care about the ordering of those 2 new transactions that I just drew, right? So here's how it works. If you remember, our one reduction rule in the pi calculus was this one. It's the COM rule. And the COM rule says, all right, take a send, take a receive, and they reduce to this thing. In particular, they reduce to whatever was in the continuation of your receive. So let's just pretend, I already had an example here. We said this was like X bang 5, and this one was like Y bang 3. So my question is, if I'm gonna make a reduction here, this is a COM, so I'll label it COM. If I wanna have a COM event where one of the terms is Y send 3, what is the other term? What does this other UTXO have to look like in order to COM with the Y bang 3?
Why, question mark?
Yeah, exactly. It has to be a receive. That's how it can COM with a send. They always have to be on the same channel. And so I'm basically saying like receive something from Y. Now I'll bind some variable to it. We'll just call it V. So receive some variable V from channel Y. So V is going to bind to 3, and then do some continuation. And maybe we'll say our continuation is like P par Q. So instead of writing in a fully concrete term there, for the sake of like fitting it on the whiteboard, I wrote P par Q. But of course, P should be some concrete term, maybe another sender receive. And likewise, Q should be some concrete term, another sender receive. Mm-hmm. And so what we've done now is we've consumed those 2 input transactions, the Y bang 3 and the Y listen for V, and we've created 2 new outputs, and they're whatever happened to be in the continuation. And in this continuation, it was P and Q. And then in this case, we're subbing in 3 for all occurrences of V. And so now our transaction DAG, it doesn't have these top 2 UTXOs anymore, but it does have these 2 new bottom ones. And the beauty is, at the same time, someone else was making a pi calculus reduction. You can think of this as like transferring cryptocurrency or breeding CryptoKitties or whatever. They were making another reduction right here, and we didn't have to have an ordering over these 2. So maybe I'll like leave it at that right now. I've done some more thinking about how we can do, like chain merges and chain forks and different like composable sharding solutions and stuff. But that's sort of the big idea right there. That's how we can have a Turing complete computational engine like EVM, but still have it concurrent like Bitcoin.
Yeah, and so kind of the most interesting part about this is that you couldn't really achieve this with like a lambda calculus. Like I couldn't imagine how you could create like a DAG-based computation structure where you could inherently make things parallel. So yeah, it's definitely something specific to the pi calculus. Like it's like the language guides the architecture, and in this case, they kind of just match up perfectly. Even though a UTXO is not exactly like the right word because it's an unspent transaction. It's it's supposed to represent like the flow of money. So it's really just like using the DAG-based approach, but you can definitely see the similarities.
Well,
unspent is definitely the wrong word when it comes to.
So according to Greg, though, that connection between currency and the messages that are passed around in like Pyro calculus is like so close. That was like the topic of the podcast yesterday, and he makes tons of connections, and I think at one point said that it was almost literally the same thing. So it's Not bad terminology, that's for sure.
Yeah. Yeah, I guess maybe unconsumed is a better word than unspent.
Yeah, right. Unconsumed resources or something along those lines.
Yeah.
So he was talking about this design specifically?
No, he was talking about the type unsafeness of money and how that leads to subjective valuation, and then talking about how you can like enforce a type safety for currency, and that will lead to like objective valuation, which I thought was a really interesting notion.
I remember his paper, Linear Types Will Save the Blockchain, I think it's called.
Oh yeah. I looked at that a really long time ago when I was first getting involved with our chain stuff.
I don't know if I've seen that one. Linear types will save the blockchain.
I think that's what it's called.
Oh, I should definitely read that.
Yeah, I remember there was that one, and then there was like types as policy or something along those lines. And I definitely didn't understand the punchline when I read it. You know, it was maybe almost a year ago, actually. But yeah, I should look back into those now.
Are you using?
Sorry.
I was just wondering, like type safety, as I know it, like I don't see the connection between that and how like the semantic properties of money really. Like to me, those are two separate issues.
Yeah, his analogy was in like languages. I think he said C. I don't have any experience in languages where you can do this like casting business, but he was saying, you know, you can kind of like take a term and then do some operation where you basically forget all of the type information and then recast it into like whatever type, and basically like you know, enforce the type of this thing at this point. And his analogy was essentially like you can turn currency into any good or service, and basically like you know, any good or service can be turned into currency. And so that was sort of his analogy, is like you can use currency for basically anything, so it's not constrained in that regard. But then the type safety currency, or the type safety aspect of currency that he was suggesting, to me kind of sounded a little bit like tokens that could specifically be used for you know, certain tasks, or you know, something that definitely already exists that I was thinking of as he was talking about it was you know, store credit or like a gift card or something like that. And it makes sense how this, you know, leads to like an objective valuation of the currency, because you know, I could go to a store with a $50 gift card and like I'm definitely getting that amount of goods or services, whereas you know, maybe they can, you know, okay, maybe it's store credit, right? And like I have some certain amount of store credit, but the store could potentially change their price for the goods or services, and like those credits could still be used for exactly the same stuff.
I think we have to be clear here that when Greg's talking about typing, he's not, you know, he's talking about behavioral typing.
Behavioral typing.
About social contracts.
Yeah.
It's, I guess, in principle, you know, it could be static, but in practice, since you don't have the state of the whole universe, it has to be dynamic.
Mm-hmm.
And
I've been trying to understand the difference between dependent and behavioral types. I don't know if anybody knows.
Jay, can you give us a like summary of dependent types?
Yeah, so I mean, I understood them a lot better once I finally started looking into Idris, like Haskell with dependent types. But it's basically just a type that can depend on data in the program or a value. So the best example that they give in Idris is if you want to do matrix multiplication, then in Haskell, you know, it's kind of something that you assume in the type class that they'll align M and N with N and M.
Oh yeah.
the dimensions. But in Idris, you can make it so that it's part of the type safety of the program, that the data of the dimensions that you input will cause the function to be of that type, and the output type will be the dimensions of the input types.
Okay, so you're saying there can be like a type class called matrix or something, but it takes some parameters. But it takes it's weird because it takes like value parameters, not type parameters, I guess, right? Because I would want like a matrix of 3, 5 or something.
Yeah, exactly. And that it doesn't even have to be a type class. It could just be a normal function where you have some matrix type that is dependent on the inputs, the row size and column size.
Okay.
So it's basically like up to the compiler at that point to check whether all of your matrix multiplications are going to line up with their dimensions, so you can verify that at compile time.
So what you need some information at compile time to do that though, right? Because I'm thinking of like some simple program that like asks the user like, tell me matrix 1, okay, now tell me matrix 2, and then multiplies them, and like we literally don't know what the matrices are until runtime.
That's a good question. I'm not great with dependent types.
I'm way better than I was 10 minutes ago, though.
Yeah, definitely a good question. If Thomas Love were here, I'm sure he would know, right?
Yeah.
Yeah, I mean, he was saying that Rolang has dependent types, and the way I understood what he was saying is basically like, if you have a receive, that is going to take in some variable. It's going to depend on the type of that variable, and that's going to, come from like some send that could eventually come with this receive.
Yeah, I was thinking about that when you were showing this today, Joshi. Is like, you're creating new processes from processes, which is very cool. It creates like this dynamic topology and all that. But the reduction and the input values will affect the processes and how they work.
Yeah.
So that's very similar.
Yeah.
We use dependent types all the time in C++. Just like generic template code is like, that's the definition of what you're talking about, where if you create like any of the STL objects, like a standard array or whatever, where you're passing in the size of the array, the type information of that array is part of that value that you passed in.
So you're saying if I have like an int array of length 5, are you saying the fact that it's an int array, like int is part of it, or 5 is part of it, or both?
So not like a C style array, but a standard STL array is templated on the type of the elements that are stored and also the length, and you can pass this int5 array between functions, and it wouldn't accept an int4 array or whatever, because each one of those is a unique type.
Mm-hmm.
Yeah, I don't know if it's exactly the same though, because Rust has something similar to this, and I know that at least if it's the same way as it is in Rust, that's part of the static type. So like each array length is a different type at compile time.
Yeah.
And so this would be more like, rather than it being part of the type, it's part of the data of the program. So it's like an actual value. So types can be dependent on data, which is not something I've seen anywhere else besides Idris.
I think another thing that was striking me as interesting was when you're talking about the senders and receivers. I know C++ is overhauling their execution context model in like the 20 version, and they've been struggling on this for years. And just following the history of it, it's interesting that now they're converging on this really generic solution, which they're calling like a sender and receiver system. And it sounds like they're basically just doing the exact type of pi calculus that you described, where they're trying to break this down into the fundamental elements in order to like make a concurrency model that makes sense for everyone's uses. Maybe I could link you to one of their papers on it.
So
Yeah,
I don't follow C++ very much at all, but that sounds really interesting. And implicit in there's a new spec coming out next year or soon.
Yeah, the C++ 20 comes out. The execution stuff's not going to make it, but they've been working on this for a decade now at least, and you know, it started out as one thing, and people keep iterating on it, and it's just interesting that they basically are converging on this pi calculus style language for everything.
Yeah,
It's the future.
C++ is always one step ahead. I feel like they're doing stuff that other languages are just catching up on.
So, hey, I wanted to share this anecdote or this like example or about behavioral types that I heard Mike Stay present once. So I couldn't tell you the difference between behavioral types and dependent types because I didn't know dependent types very well, but I can start to guide the intuition about behavioral types. So Stay's example is if you imagine searching for a function, if you want to like find all of the functions who have a particular type signature, for example, and then let's just to think of a concrete example, let's think of the type signature like int list to int list. So I have some function where I give it a list of integers and it gives me back a list of integers. And so he says then like, okay, think about all the different kinds of functions that you might find if you did that query, things that give you, take an int list and give you back an int list. Well, there's a bunch of them. There's a bunch of different shuffle algorithms. There's a bunch of different search algorithms. No, not search, but like sort algorithms. There's the identity function. There's the one that just swaps first and last, like you name it. There's a million of those functions. But if you add behavioral types, then what you can do is restrict like, you know, the set of results even further by saying, okay, give me all of the functions that take in an integer list and give me back an integer list and have the post condition that the final, like the resultant list is sorted according to this ordering that I, you know, specified or is hard coded or something. And so then you're able to reduce your result space from anything that goes int list to int list down to things that actually sort, because you were, the behavioral type also specified that post condition that the list has to be sorted. So then you know, in general, like you get rid of your shuffles and your identities and your chop off the last items and that kind of stuff.
So is that, that makes me think of a trait or like a type class or something. Like something, any type that's orderable, right?
Oh yeah, like for that example, we definitely would have to have that restriction that they be orderable, right? But okay, so let me refine the example then. So imagine the function signature that I searched for is like orderable x, and then it takes in a list of x and gives you back a list of x. So the fact that x is orderable is different than saying that the resultant list is actually ordered, that like every pairwise comparison returns less than or something in that ordering. So it's like, yeah, definitely in like Haskell or Rust, you can specify like I need this, not just integers, but like more generically anything that's orderable. But then with the behavioral type, we can say like, okay, I want the function that I'm trying to describe here, that I'm writing a type for, it needs orderable x, and it takes in x list and it gives back x list. And now here's the behavioral part, that resulting x list, every pairwise like order comparison has to say less than, or however you express that the final thing has to be sorted.
Oh, okay.
Yeah.
Huh.
So that's like pretty much the extent to which I understand it. I don't know if we can go too much deeper than that.
That's pretty cool.
So you're saying that, you know, so the behavioral type says, I want to call, I want to call something here which sorts the list, but I'm not specifying how that sort is to happen.
Yeah, that's right. So like in that example, the behavioral type specified that the final list be sorted, but we still have, you know, our bubble sort and our merge sort and your favorite sort and whatever. Yeah.
Yeah.
So you can swap out the sort algorithm and you won't break the program.
Yeah, right. Oh, that's actually a really good way to think of it, Jim. So like with the behavioral type, we could swap out like bubble sort for merge sort and the program wouldn't break. But if we swapped out bubble sort for shuffle, then the program would break. And if we went back to just our old type system that didn't have that behavioral piece, like in a Haskell program, I could swap out sort for shuffle without breaking, without violating any of the type constraints. But now my program doesn't run right anymore because my list wasn't sorted.
Yeah, that's cool.
Yeah, that's like a really interesting topic to me right now. Like, all of these languages that have static typing are just capturing like this really bare implementation type interface. And it's so hard to actually try and capture like the semantic meaning behind what you're trying to give to a function.
Yeah, definitely. Yeah, even like going into Haskell, you realize so quickly that, even like the most fundamental type class of Haskell, like the monad itself, its behavior is implicit. When you're writing a monad, there's no guarantee that it's going to be compositional and associative or whatever it is that makes it a monad. You just kind of have to prove that on your own and then write it into the program. I think Idris allows for you to change that, but I'm not exactly sure how it does. But there's definitely some kind of way to do it.
Yeah. So I'm not that great at Haskell, but I think I understood what you're saying there. So you can be like writing some implementation of a type class like monad or functor or something. And like, the type system can like verifies that you've written all of the functions you were supposed to and that they have the right type signatures and everything. But then separately from that, there's also these properties that, like you read about in your tutorial or your reference book or whatever, where, I don't remember what they are, but maybe you're supposed to have an identity or like some particular function is supposed to be commutative or something like that. And there's really no enforcement of that. And I could like implement a particular type class in such a way that it type checks, but by not satisfying those sort of like additional implicit properties, then it's probably going to break people's expectations of what a functor is or something.
Yeah, exactly. Like the monad has to be compositional. That's the whole point of it. But I can easily write a monad that's not compositional and will give back like really weird results. That's not, maybe the result of the second put into another one or something like that.
Yeah, but it still type checks.
Yeah, it still type checks because all it checks is that you take something of one type and a function and another thing of a type, and it gives you back another thing of that type. That's the monad. Or the functor is an easier one, which has the same issue. The functor takes a type and a function, and then it gives you back something of that same type operated on that function. Well, I could just return back the same thing, almost like the identity, without even using the function, and that would compile in Haskell just fine.
Yeah.
So, I guess just going back to the UTXO discussion, like I was following you, I kind of like, I'm still trying to wrap my head around why the UTXOs themselves are ordered. Like my understanding of it is, that's not something that's communicated between clients. It's like all volatile constructed in this whole, like each node itself is responsible for constructing its own belief of what this UTXO array or whatever it is on their own machine.
Yeah.
And therefore, to me, it seems like it's not really ordered, right? Like, can't they just decide how it's going to be represented in their own system?
Yeah, that's a good question. I'm not sharing the screen anymore, but I'm just going to bring that diagram back real quick. Yeah. So like, that's so glitchy. Sorry. Yeah. So the transaction. So here's the deal, right? Yes, every node constructs its own like local view of what the UTXO set is, and in Bitcoin, the UTXO set is the state of the whole machine, right? That's the thing that we care about. And anyone is free to have their own view of what the UTXO set is that's widely different than anybody else's, right? Like I could have all these transactions where people are paying me money and I'm like, yeah, those are real, but no one else believes me, right? So if Bitcoin is going to be like a currency that people can exchange with, we have to have at least mostly a common understanding of what the UTXO set is. Because otherwise I'll show up with what I consider to be a perfectly good coin, offer to pay it to you, and you'll be like, oh, that's not in my UTXO set, we're stuck. That kind of thing does happen at the very tip of the blockchain, but the purpose of having the blockchain is that we should be able to reach consensus on what the UTXO set is, and therefore still be able to interact with each other. Because, again, if we have widely varying understandings of what the UTXO set is, we're never going to be able to interact with each other. So at the most fundamental level, that's all we need, is a common understanding of what the UTXO set is. Now, there's lots of ways to do that, and people are calling them consensus algorithms. And the one that Bitcoin chooses, it doesn't have to be this way, but the one that Bitcoin chooses is to say, okay, whenever there's a conflicting transaction, whenever there's a double spend, we need some way to resolve that, because that's when people get out of sync, right? Like if everybody's honest and only spends the coins that they have all the time, then it's easy to have a common understanding of what the UTXO set is. You just have to make sure you've heard of all the transactions. But when it gets tricky is when there's a double spend, like block 3 and that block that transaction 3 and that transaction that I crossed out with an X. Those are competing. And no one can have both of those transactions in their history at the same time, because they both, they're consuming that same one UTXO. And so we need some way to decide, and to all decide the same thing, which one's going in. Is it 3 or is it the one that I crossed out? So Bitcoin's solution is, okay, let's just put a timestamp on every one of these things and see which one happened first. And so whichever one happened first, like if transaction 3 happened first, then it's the real one. Or if that X'd out one happened first, then it's the real one. And then, everybody can agree on that and we can move on. So with Bitcoin's consensus algorithm, they said, okay, we need to know in some cases which one happened first. We need to know whether 3 or X came first. And an easy way to do that is to just know of any 2 transactions which one came first. And I agree that's simple, but the problem is it takes away all that concurrency that we could have had. I don't know if that got at your question or not.
Yeah. Yeah, I guess I just, and Jay was talking about this at the meetup too, like, I kind of get lost where, I don't see how you could really reach a huge amount of concurrency, because it does have to be eventually serialized into some persistent data structure.
Okay, yeah. So I think that's the crux of it. Like if you're insisting that it gets serialized into a data structure, then yeah, you're not going to have, like, serialized is the opposite of concurrent, right? But it doesn't have to be a blockchain. The consensus data structure, which is different than the transaction data structure, can also be a DAG. The game that we're playing consensus on can be a DAG as well, where the blocks don't have to be totally ordered.
Yeah, so just like Hashgraph.
Hashgraph is a great example.
Yeah.
I think Libra's like that too. Like the data is not stored it's stored in some kind of like growing Merkle unbalanced tree or something.
Yeah, that's right. You were saying that he was saying a 3-dimensional Merkle tree. I was just like, what the hell? But
that sounds interesting. Have you guys read into Libra?
Yeah, I read through their paper. They have a more technical paper where they discuss like all the decisions that they made. I mean, honestly, it does seem pretty interesting to me. I think like they made some horrendous decisions driven by the business side of it rather than the technical side, which is unfortunate. But like, you could tell that they have really smart engineers that were working on this for a very long time.
Yeah, I'd love to read it. I'm not anti-Facebook in general. If they're doing it right, I'm down for sure.
I am in general, but I'm willing to make an exception.
Yeah, maybe that's a better way to say it.
I'm willing to make the exception to allow them to expose billions of people to the idea of cryptocurrency.
Yeah. And yeah. But yeah, they also, with their language move, it has built-in linear types. It looks like they took a hint from Greg Meredith.
Yeah, they, it seems to me to be very unlikely that they will be allowed to do that. And the trolls already seem to be getting a lot of political power behind making Libra illegal, and claiming it's going to just disrupt the world financial systems and all kinds of crazy stuff.
Yeah.
But even people I know and love are in this, have caught up now in this fight against Libra.
Yeah, I mean, it would be a mess if it works, but if anybody can get through all the regulatory craziness, it's definitely Facebook. I think you need a ton of money.
Been there, done that.
But that that would set the precedent. That would open it up for the rest of us.
Yeah.
We would have the competition against the central bank system.
Mm-hmm.
I have a lot of sympathy for like the engineers at Facebook, because I was in a similar position where I feel like a lot of engineers are like this, where they're working on something, and from a technical standpoint and a engineering, like just solving problem standpoint, you're driven to do things in a certain way, and that's the way we all are oriented. But like in the real world, a lot of times what happens is the businessmen come in, and they have to figure out a way to turn your engineering solution into like a product that's viable to the world. So I think that's kind of what happened with the Facebook thing. Like, they have a lot of cool ideas, and you could tell like they're really smart, but some of the decisions that were made in Libra's case are clearly like were driven through business interests rather than like trying to solve actual technical problems.
Hmm.
Yeah, I think they played the business very. By teaming up with Visa, MasterCard, and they didn't fight anybody. They joined up with them, and if anybody's going to succeed, I agree that they could, except that history records that the money power can't be beaten.
That's an awesome background, Gary.
Thank you.
Oh yeah, nice.
Yep.
So do you guys work together on a specific like a new type of generic language mostly, or like what's going on with this Discord mainly?
Are you Mike? Are you talking about the Colab Discord?
Yeah.
Yeah, the Colab Discord is sort of a joint project that sprang out of at least two different major groups. One was Archain, and the other was the Dig Life Collective, the Archain Cooperative and Dig Life Collective. And we kind of use this for a more open playground to work on things we're interested in that may be more or less connected to those other projects.
Yeah, I think the whole vision of being able to control a world computer in an algorithmically constrained manner using a process calculus which is the only way to control asynchronous communicating processes in an algorithmically controlled manner, is what brought us all here, initially behind RChain. Is that correct?
So RChain is kind of like a program language version of like the IPFS file system idea, where many people can participate in like a global computer.
Yeah, RChain is a world computer that's based on the process calculus, actually the row calculus, the mobile asynchronous communicating process calculus. And where our interest is here is beyond any single implementation of it. Rolang is the language of RChain, and we're looking at variations of Rolang, written in K framework and Joshi's Roxy and et cetera. So I mean, so the RChain and related architectures is what draws us here.
Yeah, and the Colab is kind of just split into different channels, each one covering, a certain topic, like computational calculus, which is next, consensus lab. There's one on substrate where Joshi will teach you about substrate. Looks like we just got a K framework channel. Is that you, Isaac?
Yeah, I started that one yesterday. Yeah, Jim suggested that I do that, so start it. I'll see where it goes. Yeah, hopefully we can have some good conversation.
Yeah. I want Robot to be able to speak the K Rolang.
Oh yeah, all right, that would be cool.
Yeah. So that's on the schedule. As long as Joxy, we also want to speak Joxy.
Joxy.
I thought it was Roxy.
Yes,
well, Joshi's Roxy.
Oh, okay.
Oh, but going back to we said a lot of reasons why we all originally came here, but I just wanted to conclude that discussion with the reason we all continue to come here is for the great conversation.
Yeah,
absolutely.
Jim, you might share the weekly calendar with Mike and Nick, so they could explore some of the other Zoom meetings that the Colab has during the week. And the calendar is sort of a mix of Colab work studies and also some RChain meetings as well. So perhaps they might be interested in attending some other meetings during the week if they want to explore.
The calendar's pinned to the general channel in the Colab. So if you go into the Colab, normally you'll be in the general channel, and you see pinned here the.
You're not sharing your screen, Jim.
Oh. So we have the calendar link here, so we can jump there. Calendar link, and then if you click down here, you can add it to your Google Calendar, or you can look at the weekly view and see we have work studies. schedule these meetings on there. Tomorrow is Dan's office hours or community building hours, which is usually pretty awesome.
Yeah, we're working on Idris in Dan's office hours, which is a computer language. We say dependent type computer language. I forgot the expression that they say distinguishes it from other languages.
Yeah, we were talking a little bit about that earlier.
Oh, yes.
That's cool. When are those office hours?
So it's tomorrow. So some of us are in Eastern time. So it's 10 a.m. Eastern time. So Jay, I guess you're in Texas. So you're Central time. So looks like 9 a.m.
Cool.
Yeah.
Sounds good.
And so Dan's working on this. He's got a secret paper. He can't tell anyone what it is or where it came from, but he's working through all of the math on it. As he works through it, he's kind of learning and teaching at the same time. So everyone on the call can kind of learn Idris through his process of digesting this mysterious, mystical paper that he's working on.
Why won't he? Why is it so mysterious?
Oh, he told the person he's got the paper from he wouldn't release it yet.
Just the idea.
Yeah, there's some kind of hold on it. They probably got a paper coming out or something, and they want to, what do they call it? Embargo the paper until it's released for the public.
Yeah.
Mm-hmm.
Is it a white paper or an academic
I think
institution?
it's academic. Yeah, I know. Dan's work on it is academic.
That's interesting.
And Dan, I believe he worked with Berners-Lee on back in the day on getting the World Wide Web set up. So he's been around a while, not as long as Jim has, but
Actually, Dan and I joined about the same time back in '92.
Okay.
So we worked together then, and he's still amazing.
Yeah. So his programming skills are pretty phenomenal, given what other programmers or developers have said. So and he's willing to, having office hours. He likes to, teach and show people what he's working on. So he's generous with his time. So we're fortunate to have someone of that caliber in our community who's willing to, kind of, teach us what's going on and expose us to other areas that we would have never have encountered. So yeah, it's good.
And teaches. Of course, I never learned, but he teaches us how to work effectively. Documenting and obeying object capability model, and
Yeah.
it's just an example for us in so many ways of what we should be doing.
Sure.
You guys are recording those office hours, right?
Usually, yeah.
Usually, okay. What kind of stuff have you guys been doing in there? I mean, I'll take a look at the videos, but just because I would like to come tomorrow and don't want to come in completely blind.
Yeah. So I want to say the last two sessions have been on Idris, working through this paper, and then so before that he was
Electronic rights transfer protocol is
Okay.
the most exciting thing that he's done recently, in my opinion. I mean, the K framework stuff. I mean, the Idris stuff is pretty deep, but the electronic rights transfer protocol is something that appears to be essential to what we're doing, and we're just going to have to adopt that. I think Greg is on board with that, but he's explained that to us very well.
Yeah, and I think that was with the Agoric smart contract conversation. If I recall, that was going back 3 or 4 weeks.
Yeah.
So yeah, that was enlightening as far as what their Agoric apparently has been working on smart contracts longer than anyone has, going back into the early 2000s or 1990s. So yeah, and so that was enlightening conversation as well.
Dan appears to be something of an expert in this area as well. He certainly knows more about it than anybody I've ever run into.
Yeah. He so and maybe we can and whatever, he always asks what is the group interested in talking about. If he doesn't have an agenda, we can kind of go off and explore in different directions. So maybe we'll see if he has anything on Idris for tomorrow, but we can explore the electronic rights. And yeah, I think that was there was a request for him to go over that again. So
cool.
Yeah.
Yeah. So what is what's this electronic rights transfer protocol about? I mean, I guess the name is sort of suggestive.
Yeah.
So here,
why don't you take it today? I tried it the other day and I didn't do a very good job.
Yeah. So here's a use case example. So
Cool.
I've got a tickets to the Tampa Bay Rays baseball game, and but I can't go. And Gary, he's interested in the tickets, so he wants to buy. So I create a smart contract that for the next 24 hours, Gary has the option of buying the tickets. Now, Gary finds out that he can't go either, and he wants to transfer the rights to purchase those tickets to Mike. But currently, that transfer of electronic rights is it's only to Gary, and currently he doesn't have the ability to transfer that ability to purchase those tickets to Mike. But with rights transfer protocol, now it exists. So Gary has been given that right to purchase a ticket. He's not able to use it, so he transfers that ability to purchase those tickets to Mike. Now Mike can purchase those baseball tickets from me within the 24-hour time frame set with the smart contract. Kind of the gist of what's going on in the world of Agoric, and it's
something that lives on top of object capabilities. Jim mentioned that yesterday, and that sort of turned the light bulb on for me.
And what they've done is taken JavaScript and created, because JavaScript doesn't have the rigor of security, so they've created a subversion of JavaScript called Jesse. And in Jesse you've got this robust object capabilities and constraints that almost like behavioral types, I guess, that you don't have with traditional JavaScript. So you get this additional functionality. So and then so there's a few videos on YouTube that anyone can go and explore. so you can do a search with on Agoric, and I want to. I'm trying to think of the fellow who was the author of the concept, Mark Miller, I want to say. So he's
Marcus Miller.
Marcus Miller. So if you, yeah. So and he apparently was working with Nick Szabo back in the day, and I think Nick Szabo coined the term smart contracts. So that's how far Mark Miller goes back. But yeah, it's a tremendous video, Mark Miller and Agoric, to help get oriented on this electronic rights transfer protocol.
Yeah, and it provides the motivation for the necessity of ERTP.
Right, exactly. So in blockchains, the future of blockchains will want to incorporate this. So it's encouraging to see that our chain is kind of moving down this path, with behavioral types and these feature sets, which they'll want to be rolling out after the mainnet launch, sometime thereafter. So you've got a blockchain and you've got a payment system, but what can you do with it? That utility. So expanding that utility with this transfer of electronic rights, then you really put some muscle power into it.
Yeah, that's pretty cool. So it's kind of like this transfer of electronic rights. So somebody originally established as a smart contract that gives somebody the rights to do something, and then it's just that person transferring those rights that were kind of laid out in this original smart contract, right? That's kind of how I understood what you guys were.
Right. So now you have portability of a smart contract, and that portability is that special sauce which gives the additional functionality, which I think is going to take everything to the next level.
Yeah, that's really cool.
Yeah, essentially it's a programming model where you have what they call bats, which are just
containers
for some trusted, it's trusted component, but it's untrusted globally. And you have secure communications between bats, and using that model, how we can, in a trusted manner, handle things like escrow in a transaction and other things becomes provably correct. In extending basic object capabilities to more complex contractual agreements.
Agoric is not a blockchain. It's not a blockchain platform. They're strictly smart contracts. So they need to build on top of a blockchain platform, or they that's what they would like to do. So they're exploring substrate. So because their substrate is being able to pick and choose your blockchain and your consensus model, and apparently so it's either substrate or Cosmos is another platform that they're considering building on. So and I know nothing. I know very little about substrate from what Joshi has discussed, and Cosmos is whole new topic for me.
Yeah, I've heard of it in passing, but I don't know much about the project. That's kind of cool though. So they're language and platform agnostic, and they're just trying to build smart contracts on any platform essentially.
Yeah, well, so it's using that JavaScript sub language Jesse. So
okay. I missed that part. They're the ones that have created this Jesse.
Right. So Agoric Right, they've created the Jesse JavaScript, which provides that additional level of security through through the through the typing, and but they it's not so Agoric and their smart contracts. It's not a blockchain platform, so they want to partner with Substrate or Cosmos, or perhaps even somebody else that's out there.
Yeah, that makes sense.
Yeah.
You know, I was looking at Substrate recently. Jay mentioned it to me. It's pretty interesting. So what I've been working on is a similar level of abstraction framework for people to build, whatever peer-to-peer or blockchain app. And my main motivation for doing that was, I worked at an access control company, and we were researching how we could get like an access control service as a backend for the stuff that we were already doing for security companies. And there was just we couldn't find any real like options as developers. Like all we really could do was make like a solid programmed Ethereum token, or like try and fork some existing token based currency. So that's why I started doing what I'm working on. It's trying to make like a generic type library for people to just get started from a ground level on whatever app they're working on.
Interesting.
Yeah, cool.
And Substrate, Jay heard what I was talking about, and he was like, oh, you should check out Substrate. Substrate's really cool. It's like, basically the same type of thing, and it feels a little bit constricting in like what it tells you need to do. Like you're kind of forced in this situation where you need to use their networking protocols and their backing blockchain and their WebAssembly like node system. So, but I do like the direction that they were going, where it's like actually providing people with code-based solutions rather than like something like IBM. Like we've seen, me and Jay were at a IBM talk earlier this week, and it all seems so wrong. Like they're offering these services where you can sign up with a mentor, and they have like cloud services where you can deploy a cluster of their Hyperledger or whatever.
Mm-hmm.
And to me that just seems like another type of centralized application service. And I think a lot of people are doing this, where they're basically just recreating what we already have with centralized databases.
Mm-hmm.
So it's cool to see people like Substrate actually trying to solve the problems for people.
Sure. Yeah, and so for everyone, the company is actually Parity. So Joshi works for Parity, who's creating Substrate, and I understand, and I believe they're working on Polkadot as well, which is another project, and I'm not clear on what exactly Polkadot is. But and then in all that mix, the consensus that they're using is Grandpa. So yeah. So
well, that's their finality thing, right?
Yes, Grandpa's their finality. Uh-huh.
Well, what I think about it.
Nope, you're on mute, Mike.
Oh, sorry. Can you hear me?
Yeah, we can hear you now. For some reason, your mute keeps going on and off.
Oh, my bad. Yeah, so
Seems to be voice activated.
yeah, I was just, I think it's interesting how like consensus algorithms keep on improving. What I'd really like to see in a new type of token system is maybe like a way to maybe like a governance type system, but some way to change the underlying consensus algorithms or any parameters of the network without requiring like a fork of the system as it's running. Because like I think it's an inevitable issue. Like if we make a new token today, or cryptocurrency like Libra, for example, and it's using the top of the line, whatever hot stuff program algorithm that the Facebook engineers worked on, in 10 years time, it's going to be inferior to whatever someone just came up with, that day. And, I think it really needs to be like part of the system from the get-go. How is the system going to upgrade over time and deal with scaling issues? So, and that's something I haven't seen anyone really deal with. I don't know if you guys have seen any tokens that are really focused on scalability like that.
It's interesting that you mentioned that. I don't understand a whole lot in the direction of the error correcting code business that Greg and some others in the Archain community have been talking about. But they are essentially claiming to have a solution to what you were just describing, being able to adjust the protocol like kind of live as the system is already online. And he's saying it in a way where he's using error correcting codes to do it, which I'm not 100% sure how all of that really works out. But I know there are some videos and some discussions of him at least talking about the idea. I don't know how much detail is actually out there, but I know there's something with Archain in that direction.
Thanks. Greg has also talked about how you can dynamically change consensus protocols,
right?
Outside the context of the error correcting codes as well. From the mathematical level, how you can make it work.
Is Greg someone who's regularly on these calls with you guys?
No, but he's on Monday mornings calls at 10 a.m. New York time, which is also on the calendar.
Cool, I'll show up to that.
Yeah, that's called the Casper Stand-Up. So it's the focus is on correct by construction, CBC, Casper, and what the current development is on Archain. And there's a fellow by the name of Kent Chikama who's leading that effort. So, and the morning goes, it's usually Kent, Greg, and Gary shows up, but usually it's just Gary and Greg are Kent and Greg giving updates on the consensus protocol what they've been working on, and then
he gets very academic, and those talks are much more interesting. And I'd like to recommend the talks on the subject of error correcting code in consensus.
Mm-hmm.
And then they'll go into Greg will go into more other topics, more of a technical detail. So, and they're not necessarily consensus related. So you can look through the archive of that I posted of the YouTube videos for Casper. They're not listed as far as what the topics are. But it's within the past, I would say, last 5 Casper videos. He's went over error correcting code, and also on the Archain blog, if I correct, there's isn't there an Rcast on error correcting code? I may be mistaken.
Yes, maybe more than one.
Yeah. Okay.
Yeah.
And those are also excellent.
Yes. So, and you just simply Google RChain, RCast, and then. And what's nice about the RCast is you've got the transcript, so you can follow along with the transcript, and make sure get a better understanding of what's going on. And Isaac here on the call is a lot of times the resident mathematician on the call, providing feedback, play-by-play feedback of what the conversation's about.
Yeah, mostly just trying to get an understanding and hopefully make it clear enough so other people also understand what's going on. Because I know Greg likes to just go on his tangents, and he's got 10 million ideas going in his head at one time, so you kind of have to slow him down for a second so you can catch up.
I'm going to jump to the RSong Zoom session here, but it was a pleasure meeting you, Mike and Nick. Enjoyed having you on the call, and look forward to chatting with you guys again. Have a great day.
You too.
Yeah. Take it easy, Steve.
Yeah, you too.
See you, Steve.
Yeah, so usually I have something to present around this time, but the last couple weeks my computer's been dying, and I just recently got a new one, but I haven't been able to set it up yet. So I just got it yesterday. So I don't have anything to show right now, unfortunately. I typically show some work I've been doing in K Framework. What's that?
What computer did you get?
I got an HP Pavilion. It's got like an 8th gen i7 processor and 32 gigs of RAM, and yeah, it should be nice. I hope it works as well as it says it should on paper.
Yeah, I got an i7, and I love it.
Yeah, I hope to be saying the same thing in like a couple weeks.
I got the Lenovo. I started looking at the Dell, and then I finally decided on the Lenovo for camera location only.
Oh yeah.
Those Dells have the camera down at the bottom
of the screen.
Yeah.
Oh, weird. Oh, so I'm assuming the Lenovo's got it up at the top.
Yeah.
Yeah. Okay.
And I'm talking about the thin laptop. What do they call that model? It's the convertible. The touchscreen. You can flip it and turn it into a tablet.
Yeah. I know what you're talking about. I don't know what it's called though. Yeah, I went with the desktop this time. I thought maybe it would give me a little better performance, because I killed that last laptop in about 7 months.
Yeah, I've started running into a few performance issues running some of these graphics programs on the Code World.
Oh yeah, cool. Yeah, I don't know if it's like the compilation in K is like really demanding or something. I mean, because I'm running that operation like several times a day, as I'm like building the code and then trying to see if things work still. And yeah, man, just killed that laptop way faster than I wanted to.
Well, guys, I'm going to head over to the RSong as well this morning.
Yeah, I think I'm going to join that too, because we have a new member who was supposed to attend, and I would like to be there to welcome him.
The blockchain artist, right?
Right. Oh, nice.
All right.
Cool.
Pleasure to meet everyone, and come back often, please.